In continuation with the series of design patterns, now we will talk about the abstract factory design pattern. Abstract factory design pattern is one of the most popular design patterns under the creational category. But before we start digging into this pattern, it is necessary to make some sense out of what is the concept of factory and factory method design patterns as well. So, a factory in the context of software design, mainly in the object oriented world, is an entity, a class, an interface, or a method that is responsible for creating the objects. That's why it is called a factory. Why do we need factory? Well, while dealing with the inheritance, we generally build polymorphic objects, objects that are capable to exist in different forms, depending upon the runtime requirements or the runtime request. That means which object will get called is not fixed at compile time. It is during the runtime the program will determine which class object it has to instantiate. And to deal with that situation, we have a factory design pattern. The factory design pattern is a way to create objects. It's like having a factory that produces different types of products. In programming terms, the factory pattern provides a central method or a class called a factory that creates and returns objects based on certain conditions. So that's why the simple Wikipedia definition of factory design pattern is: in object oriented programming, a factory is an object for creating other objects. Formally, it is a function or method that returns objects of varying prototype or class. So, here is a simple way to understand it. Let's say you are in some restaurant and the waiter takes your order and brings you the order that you have asked for. In this scenario, the waiter can is more like a factory. They take your order and bring the kind of meal that you have ordered to your table. In software development, the factory design pattern works similarly. Instead of ordering for some meal to eat, you asked for an object that you needed in a particular situation during the runtime. And then the factory method determines which type of object you need based on the conditions you provide, and it will simply return you that particular object. The factory pattern is useful because it helps to organize the creation of objects, especially when there are multiple types of or variations of object. It centralizes the object creation logic, making it easier to manage and modify in the future. So, a factory can be implemented in various ways. Most often, it is implemented as a method, in which case it is called a factory method. Sometimes it is implemented as a function, in which it is called a factory function. So there is another related pattern, or we can say an extension of this simple factory pattern, which is called the factory method design pattern. The factory method pattern again provide an interface for creating objects, but allows subclasses to decide which class to instantiate. So the intent behind factory method pattern is to define an interface for creating an object, but let the subclasses to decide which class to instantiate. Factory method lets a class defer its instantiation to subclasses. In simple words, the factory method pattern is like having a factory or a method that produces objects, but instead of the factory, it's self determining which object to create, it delegates the decision to its subclasses. So imagine if you are in some kind of a bakery and that produces different types of cakes. You want to create a system that can produce various cakes based on the customer request. In this case, you have a cake factory class with a method called a create cake. However, instead of the cake factory class directly deciding which kind of cake to create, it delegates that responsibility to its subclasses like chocolate cake factory or vanilla cake factory and so on. Now each subclasses of the cake factory overrides the create cake method and they will provide their own implementation determining which specific type of cake to create during the runtime as per the request from the client side. The factory method pattern allows you to encapsulate the object creation logic in separate subclasses, making it more flexible and extensible. It follows the principle of code to an interface, not an implementation, allowing you to easily add new types of objects in the future without modifying the existing code. So we use the factory method pattern when a class can't anticipate the class of objects it must create. But then you can say that's what the simple factory method pattern is. So we use the factory method pattern in a particular case, which is the second point, when a class wants its subclasses to specify the objects it creates. When we want a scenario where the classes delegate the responsibility to one of several helper subclasses, and we want to localize the knowledge of which helper subclass it is the delegate. Now, what if you have not just a single category or type of classes to deal with, but a whole family of related objects? In that case, burdening a single entity to do that is not a good option. It will make your code look messy, lengthy, and will also violate the single responsibility principle. So, a better option is to abstract the factory itself, to create a factory of factories. And this is where the idea of abstract factory comes to our mind. It is similar to the factory method pattern, but the only difference is that it focuses on creating families, or we can say different types of related objects instead of individual objects. So, this pattern is useful when you want to create a set of objects that work together in a specific way and want to ensure that these objects are created in a consistent way across your application. So, what's the intent behind this? The intent is very simple. It is to provide an interface for creating families of related or dependent objects without specifying their concrete classes. In simple words, it provides an abstraction, interface, or sub abstract class, whatever you want, that defines methods for creating different types of related objects, but it does not specify the exact classes of those objects. Concrete implementations of the abstract factory are responsible for creating objects of the specific classes. So, this is how the class diagram of the abstract factory design pattern looks like. The only issue that people face is that when they don't do it properly, things can get a bit complicated. I mean, you have a number of objects to manage and you can easily mess them up. So, if you can see in this diagram, we have an abstract factory, a factory of factories, from which we have concrete factory 1, concrete factory 2, and now these concrete factory will help us in designing the different categories of products: product A1, product A2, product B1, product B2, depending upon the requirements of the client. We generally use the abstract factory pattern when a system should be independent of how its products are created, composed, and represented. Remember, it allows you to create families of related objects without specifying a concrete class. We can use it when a system should be configured with one of multiple families of products or objects, when you have many objects that can be added or changed dynamically during the runtime. When a family of related product objects is designed to be used together and you need to enforce this constraint. And when you want to provide a class library of products and you want to reveal just their interfaces, not their implementations. That means you can model anything you can imagine and have those objects interact through common interfaces. Now, in order to understand how the abstract factory design pattern actually works, let's get back to the class diagram once again. So, here we can see that the abstract factory is a common interface which provides a way to create the families of related or dependent objects. They are related or dependent, that's why we have kept them inside a common interface. And that's what the intent of this design pattern is, to provide an interface for creating families of related or dependent objects without specifying their concrete classes. Now, the task of creating these products or these product objects, we have delegated to our concrete implementations. That's what the intent of the factory method pattern, if you can remember. Define an interface for creating an object, but let the subclasses to decide which class to instantiate. So that's what we are doing here. We are letting the subclasses to decide which object they want to instantiate. And how they will determine it? They will determine it during the runtime as per the request from the client or from the calling code. So we can see that concrete factory 1 is creating the object A1 and object B1, and concrete factory 2 is creating the object product A2 and product B2. To summarize, the abstract factory design pattern provides an interface or abstract class for creating families of related objects without specifying their concrete classes. It enables the creation of objects that are compatible within their families and provides a way to switch between different families.